Hi there everybody, Siggy Seroka with another weekly weather explainer for you. We're talking clouds again, I know, but this time more about the different types of clouds we see and more specifically contrails because their specificity in the atmosphere. So looking at the different types of clouds, I'll move out of the way here for you. This comes from National Weather Service. It talks about how clouds first got their names. It's from an Englishman named Luke Howard. Now basically he came up with the different names relating to Latin for heap, layer, and curl. The cauliflower looking clouds with the flat bottoms and kind of exploded tops, that's Latin for heap. Those are cumulus, he said. Stratus is more the ones that are really wide but not so thick, and they're more like a blanket or a mattress up in the sky. Those are stratus. And then cirrus is the ones that kind of look like long hair, just real waspy or wispy clouds that are stretched out. Now you have all the different types there, 4 different cloud types, nimbus also for the ones that carry rain in 3 different levels of the atmosphere. That leads to 12 major cloud types. Not all of them pictured here, but a good idea generally of what they look like. Cumulus are just the puffy ones out here, kind of in the lower to mid atmosphere. Then you get cumulonimbus. Those big towering thunderstorms lead to a lot of lightning, hail, and rain. You even have nimbostratus, which is more of those lower level clouds that bring rain. Stratocumulus that are pretty much just flat, lower to mid-level clouds that block out the sun. Altocumulus could turn into thunderstorms and showers later, but you need a lot of instability in the upper atmosphere to kind of help them get to that deep convection state. And then cirrus clouds. Now these ones up here are a little bit closer to what contrails are. This is probably a little difficult to read. I'll move out of the way in a second so you can go ahead and take a screenshot of it, read it on your own time. But a contrail is just the condensation trail. See how those words are combined? It's a condensation trail left behind a passing jet plane. That warm exhaust meets that cold atmosphere, and it works with the low vapor pressure and low temperature at that height to create condensation. That's just going from a gas to a liquid. It doesn't take much water in the upper levels of the atmosphere because the temperatures are at negative 40 degrees Fahrenheit. So you add very little water into very cold air, which is normal from combustion engines. You end up seeing these long trails left behind those planes. But these are used to actually help determine some weather. So in a drier atmosphere, these trails, they are going to be short-lived. They'll disappear very quickly if they even form behind the plane. But now when you get into more moist atmosphere or colder atmosphere, you will be seeing those contrails last for a very long time. And when they break, it's actually moving through a dry pocket there. So pretty interesting. Now there is some concerns, maybe an impact of them actually, disturbing the climate in any way in high traffic areas, lots of jet planes and air traffic corridors. You can see cloud coverage increase as much as up to 20%. That's just from those contrails turning into cirrus clouds in the upper atmosphere. All this does is inhibit some of that heating from the sun onto the Earth's surface so far. Many studies are still trying to figure out if it's impacting the climate in many similar ways, as well as what is exactly in the jet exhaust, that's impacting anything in the climate. But these are not used to spray any chemicals up there. It's just the natural process of going from a combustion engine, at least spitting out water vapor into that cold atmosphere and creating condensation. But that does it for your weather explainer. More news and weather updates right here on the Nonstop Local streaming channel.